In this video we introduce Flowcode version 4 and look at the workspace that it produces. When you click on the icon on the desktop, the first screen that opens allows you to either create a new Flowcode flowchart or open an existing one. We'll create a new one. The first decision is which microcontroller we're going to use to program. It defaults to 16F88, but there's a wide range of other devices available, including, at the bottom of the list, the Formula Flowcode buggy, the Locktronics PIC, MIAC and ECIO. We'll choose the 16F877A. The main workspace now opens. At the bottom there is the panel. This is the area that we use to add components. Down the side are the icons that we use to create the flowchart. Across the top are components that we can add to the panel as part of the program. The next window shows the PIC chip, and as the program runs, the various inputs and outputs will change colour to show what happens, what the program is doing. Down the right hand side we've got the property panel for the panel at the bottom itself. The top icon allows us to add an input to the program. The second one is an output. The third a delay, decision box, switch case icon, two connection point icons, a loop, a user-defined macro or a component macro, a calculation icon, a string manipulation icon, an interrupt, or a C code icon which allows us to add C code to our main program. Inside the panel itself we can add components including text, images and other items from a user defined area. Common devices include LEDs and switches. Inside the other menus we have a list of input devices including keypad and switches and ADCs. The outputs include LEDs, LCDs and LED 7-segment displays. Inside the communications menu we have LIN, SPI, one-wire, I2C, CAN, RS232. The wireless menu includes infrared, RFID, Zigbee and Bluetooth. The peripherals include USB, TCP/IP, MIDI and web server. The mechatronics list includes stepper motors, PWM, speech and servos. And finally, inside the miscellaneous menu we have MIAC, Formula Flowcode, EPROMs, GPS and the ability to create your own component macros. The program can be simulated by clicking on the blue triangle. The next one is a pause, followed by a stop, followed by step into, which takes the simulation one step at a time, step over, which jumps over macros and delays, compile to C code, compile to hex, and compile to chip, which actually includes the other two automatically. That concludes the first video.